Section 2.4, Algebraic Reasoning. When you solve an equation, you use properties of real numbers. Segment length and angle measures. When we have the measures, we know that they're real numbers, so we can use these properties to write logical arguments about geometric figures. So let's review these. Again, we have seen these before, but let's review them real quickly. So the algebraic properties of equality, let A, B, and C be real numbers. The addition property of equality states that if A is equal to B, then I can add another number on both sides and it will still be equal. Same thing with the substitution property of equality. Again, we could subtract the number from both sides and it'll still be equal. Multiplication, and same thing. So everybody's kind of getting the idea. We multiply something on the same side or divide. Again, on this one here, that with the multiplication and division, what's important is that we notice that C cannot equal 0, especially on division. Remember, if we divide by 0, you're going to get an error in your calculator. All right, because that is undefined. And then finally, the substitution property of equality states if A is equal to B, then A can be substituted for B or B for A in any equation or expression. All right, so let's go ahead and start with our first example. All right, again, we've done these before. We've done them in algebra, but now we're looking at the reason here, and we're going to look at the equation and the explanation. So eventually, we're going to get rid of this. We're going to call this one here justification, and we're going to have the reasons. We're going to start making two-column prose here, probably near the end of, well, even maybe next section. So once we see that that's going to happen, it'll make our life a little easier. All right, so we're going to solve 2 times x. Actually, let me go to the right problem. We're going to solve 2x minus 5 is equal to 13, and we're going to justify each step. So the first step we're going to do is we're going to go ahead and write down our equation here. We're going to say that 2x minus 5 is equal to 13. All right, our explanation, we just wrote the equation. And our reason is because that is what we were given. We were given 2x minus 5 is equal to 13. All right, so now remember, when we're undoing, we're going to do stuff, right? So we're going to go in the opposite order of the order of operations. So remember, on this here, to solve it, we're going to add 5 to both sides. So I just told you the reason that we're going to do this. So I want you to kind of think, we're going to go and write our reason here first, all right? So we're going to use the addition property of equality. So I'm sure when you're looking at your homework, you're going to probably drag and drop it. So it'll have the addition property of equality. But when you're writing them out for me or something like that, you just write the addition property. I'm okay with that. All right. So again, what does the addition property do? It adds 5 to each side. So notice I made my little arrow there. And again, when we do that, what's our result? We're going to say 2x. Let me make that 2 a little better. All right, so again, I just did it on the same line. A lot of times you would put it underneath, but I didn't give us enough room there. Again, I'm trying to keep it to 1 page for you. All right, so once we do that, then what you would do next is you would tell me you would simplify. So again, we're going to go to our next step here. And when I simplify, that means we're going to combine like terms. In this case, it's just the numbers, right? So we're going to have minus 5 plus 5 equals 0. 13 plus 5 is equal to 18. So you're going to tell me that our problem simplifies to 2x is equal to 18. All right. And then finally, our last step, all right. And again, you would tell me that you would divide. So we're going to use the division property of equality. All right. Another little thing here for you to think about is if it's on paper and pencil, as long as I can understand, I know div, to me that means division. So as long as I can understand what you're trying to tell me, you can simplify it. You can, abbreviate it if you need to. All right. But again, what's that going to tell us? It's that we're going to divide each side by 2. And when we do that, again, we'll get that x is equal to 9. So I kind of found that interesting. They asked us to combine like terms on the first one. I guess I should say combine like terms. But on this one here, they just kind of said, you know what, that 18 divided by 2 is 9. And we're all done. So that's our answer for that one, people. All right. And then again, we know the distributive property. All right, so let A, B, and C be real numbers. So we know that if we have A times, in parentheses, B plus C, we know that we can distribute that A through the parentheses. So I'll have A times B, which is right here, and then A plus A times C. All right, and again, we can do the same with division. Again, I'm going to multiply that A through the parentheses, and I'll get A times B minus A times C. Now remember, that means that, again, they are real numbers. Okay, so again, let's go ahead and do example 2 here. So what did we do on the first one there? We wrote the equation. So we're going to write 2 times x plus 1 is equal to negative 4. And again, our explanation is write the equation. And then we are going to say that our reason was given. All right. So again, we're going to kind of go down and we're going to think, what do I have to do next? Well, we're going to use the distributive property. All right. And what does that mean? We're going to multiply through the equation. And when we do that, again, we know that 2 times x plus 2 times 1 is 2. And that is going to equal negative 4. So we just did the distributive property. We're going to just go ahead and keep doing the same thing. So now to simplify that, we're going to subtract 2 on each side. So, what was the word I just used there? Subtract. So our reason, we're going to use the subtraction property. And that means we're going to subtract 2 from each side. And when we do that, we're going to have 2x plus 2 minus 2 is equal to negative 4 minus 2. All right. So now we're going to simplify. So we're going to combine like terms last time again. They have us do that for the addition and subtraction, but not for the multiplication. So I don't know why they do that, but oh well. All right, so we are going to simplify. And again, that means we're going to combine like terms. And maybe it's because we're combining like terms. I don't know. All right, and then that means that we're going to, again, plus 2 minus 2 should equal 0. Negative 4 minus 2, right? They're the same sign. They're both negative, so we're going to add them and bring over the sign. So you would be able to tell me when you simplify that you have 2x is equal to negative 6. And then to do that one there, we are going to, well, to solve for x, we need to divide. So we're going to use the division property. That means we're going to divide each side by 2. And then that would give us that x is equal to negative 3. And we're all done. Okay. All right. So some other properties. And again, some of these may sound silly to you. All right. But they're actually going to be pretty, they're going to be helpful when we start doing 2-column proofs. All right. So the first one is the reflexive property. So if we're talking about it, real numbers, A equals A. So we know, let's say A is equal to 5. We know that 5 is equal to 5. That'll never change. We can also do that for the angle measures and for the segment lengths. If AB is equal to 6, we know that its length is equal to itself, and that's not going to change. And these, I keep saying these ones seem silly, but they're so powerful when we're doing proofs. All right. So we can, again, even say the measure is equal to itself. The symmetric property just says if A is equal to B, then we can say that B is equal to A. All right, that just means I can flip it. If I can flip it to my advantage, that works. Same thing with if line segment AB, well, the distance, right? Because AB is talking about the length. So if AB is equal to CD, again, I can flip it and say CD is equal to AB. And you'll see how this is important here in the next example. All right, if the measure of angle A is equal to the measure of angle B, then we can say that the measure of angle B is equal to the measure of angle A. And then finally, the transitive property, which is similar to the law of syllogism that you just did yesterday. It says if A is equal to B and B is equal to C, then we can say that A is equal to C. All right. Same thing with the segment length and with the angles. So if the measure, I'm just going to say the angle one, if the measure of angle A is equal to the measure of angle B and the measure of angle B is equal to the measure of angle C, then the measure of angle A is equal to the measure of angle C. So I did that one here because we're looking at this next example here. So example 4, you bounce a pool ball off the wall of a pool table as shown. Determine whether the measure of angle RTP, so RTP, so we're going to see the measure of this angle here equals the measure of angle STQ. That is this one here. So again, I'll write them quickly so that we can see. We want to see if those two angles are equal. All right. So what did we do with the last two? What did we do with the last two problems? Well, we just wrote down the equation first, right? So On this one here, what did they give us? They just gave us the measure of angle TRQ. Well, what they're showing here, ladies and gentlemen, is every once in a while we're going to have to look at a diagram and see what we have. Now on this one here, I'm sure it didn't go very well, but if you look here, we have this pool table here, and we see that this length right here is one of the ones that they gave us, and then they gave us this one right here. So those are our two drawings. Let me show you again one more time. So they're showing us this one here, which is that angle right there by the drawing, and then they're giving us this one here, which is this angle here, right? Does everybody see that? So again, let's follow what I just showed you. They're telling us that the measure of angle RTQ. So again, let me show you RTQ is equal to the measure of, let's see, STP or PTS. You can call it either way, remember? Okay, so if you look at the example in the textbook, I think they kind of said the measure of angle PTS. Okay, and what's our explanation? Well, I just showed you it's marked in the diagram, right? Since it's marked in the diagram, that means that it was given. All right. Now I want you to notice this here. So the measure of angle RTQ, so we're talking about RTQ, is the measure of this angle here plus the measure of this angle here. All right. So it's the measure of angle 1 and 2. Well, they want you to get used to using the angles, so we're going to go ahead and say that the measure of angle RTQ is equal to the measure of RTP, measure of angle RTP, plus the measure of angle PTQ. All right, and again, that would be by the angle addition postulate. So what did we do? We added measures of adjacent angles. And again, we use the angle addition postulate. Let me write that correctly. Okay, again, as we're just writing this down, simplify it, just say angle add. All right. So now I also wanted to kind of think about it here. We're also going to do this one here, which is angle 2 plus angle 3. All right. So I'm going to take, and we're going to do angle addition again. All right, so on this one here, we're going to say that we're going to add measures again. And on that one there, what do we have? We have that the measure of PTS is equal to the measure of angle PTQ so that was this one here, plus the measure of angle STQ. STQ. All right. All right. Hopefully I gave you enough room there. If I didn't, write small because we have 2 more things to say. So now if we look at this, ladies and gentlemen, we can state, since we already told you that these 2 right here were equal, well, I have them both right here. So if they are equal, just think, we can substitute in for one of them. So I could like move this one up here to this, all right? Or I could move this one down to here and set those equal. Because again, what is our goal? We want to show that this angle here, RTP, is equal to this one here. All right, so kind of look at what I just did there. So we're going to substitute. We're going to use the substitution property. So let's see, what's a different color? And it would be the substitution of property of equality, but I'm not making you write the whole thing down. So we're going to substitute, I just told you. For angle RTQ and angle PTS. And what that means then is that we can write that the measure of angle RTP plus the measure of angle PTQ is equal to the measure of angle PTQ plus the measure of angle STQ. Again, I know it's kind of looking sloppy. Hopefully we're listening to me. And you can write it a little better. Okay, now look at on both of these. Do we have PTQ on both of them? I have it here and I have it here. So if we subtracted it using the subtraction property, what are we left with? We're left with the measure of angle RTP and the measure of angle STQ. And notice we still have that equal sign in there. Did we finish with what they wanted us to show? Yes. So again, on this one here, I'm going to subtract. And it's the subtraction property of equality. So again, if you notice, I didn't put just, when I have to use the subtraction and substitution, it's hard to just say sub property, because again, I don't know if you're talking about substitution or subtraction. But again, on your homework, a lot of it's drag and drop for you. So I think that'll be okay. And what do? We're going to subtract what I say, the measure of angle PTQ from both sides. All right, and when I do that, what are we left with? Again, we're going to subtract it, so that means that we're subtracting that. It's going to go away on both sides. So we have that the measure of angle RTP is equal to the measure of angle STQ. And that's what they asked us to show. So we're all done. All right. And then the last one is a word problem. So there are 2 exits from Theater 10 at the local cinema. The cinema manager wants to put a trash can along the wall the same distance from each of the 2 exits. Create a diagram to model this situation or this problem and show that the distance from the trash can to the left exit is half the distance between the 2 exits. All right. So what it is saying here is I have, let's just go ahead and draw a picture. So I have an exit here and I have an exit here. We're going to call this one A and we're going to call this one C because halfway between them, I'm going to put the trash can, which is B. Now remember, it says that I want it to be the same distance. So if it's the same distance, I know that I'm going to put tick marks there to show that AB is equal to BC. Oh, I just kind of showed you something there, didn't I? All right. And then again, what we're trying to find is we're trying to find this length here and make sure it's half the distance. All right, which we will find out. So, according to the diagram, what did I just tell you? I just told you that AB is equal to BC. And why is that? Sorry, it just kind of delayed it right there. I had it written down on mine and I didn't see it. So what's our reason? Again, we just made a diagram and we marked it in the diagram. All right, and what was our reason? It was given. Okay. So now what we have to do is we have to kind of think of what we have to do here. So if we look at it, we have from what we've had before, we know that the segment addition postulate, so we know that if we go this right here, the whole thing is AC, well, we know it has to be AB plus BC. All right. So what we're going to do there is what I just say. We just said that AB plus BC is equal to AC. All right. And why do we know that? Because we can add lengths of adjacent segments. And what reason was that? That was the segment addition postulate. And again, you don't have to keep writing the postulate, especially since you're going to be drag and dropping. Now, here's the key is you have to, we learned this in section 1.2. Section 1.2, in fact, we even had an example of it on our test. I don't want you to put the reason as 1.2 because I keep telling people it might be 1.2 in our textbook, but if you go to another school, well, it might be 2.1. All right. So we don't know how other textbooks use it. So you're just going to tell me it's by segment addition postulate. hopefully that's the way it'll do it in the textbook for me too. I mean, in the homework, but I guess I'll find out when I do the homework tonight. All right. So let's see right here. Now, we need to show that it's half of it. So I want you to kind of think here. If I replace BC with AB, which I can do by substitution, correct? Then I can add those two together and get 2 times AB. And then I can divide, which will show me it's halfway between. All right? So first thing I'm going to do, I just kind of told you my plan. Oh, notice you should try to figure out a plan. You'll find out as we're doing proofs that that's going to help us a lot. So I'm going to, like I said, I'm going to use the substitution property. Okay, which means I'm going to substitute AB, length of AB, for the length of BC. And what happens there? Well, then I'll get AB plus AB is equal to the total length AC. All right, see everybody, see what I did there? All right, and then let's go ahead and let's simplify again. All right, and when we say simplify, that means we're going to combine like terms. And what that means is I have AB plus AB. Well, doesn't that just become 2 times the length of AB? We don't know what it is, but we know it's a distance. And we know that it will equal the length of AC. All right. So our last thing here, we should be done because now all we have to do is divide. So we're going to use the division property of equality. We're going to divide each side by 2. And when we do that, again, I want you to kind of think here. I'm going to divide this side by 2, and I'm going to divide this side by 2. All right, so now I'm going to erase that. We're going to start using our head. So that will tell us that we have AB is equal to AC. Remember, I wrote it like that, divided by 2. But again, I can pull out that 2 as 1/2 of AC, which does show that it is half the distance between the 2 exits. So I did exactly what they said, and I am all done here. And I'm all done with my notes. Thank you, people.